counting. Before you continue watching, make sure to subscribe and like. The topics we're going to be covering today are combinations, combinations versus permutations, complementary counting, sticks and stones, and Pascal's triangle. Our first topic of today is combinations. Combinations is finding the number of ways to combine things or elements. And in this, order doesn't matter, and that is really important to know. Order doesn't matter. Now we're going to move on to our next topic, which is combinations versus permutations. So I have here a little table. This is our basis for comparison, and this is the things with combinations and permutations. So the definition of a combination is choosing items from a larger set, whereas a permutation, the meaning of a permutation is different ways of arranging items in a set. Also, order in combinations is irrelevant, where it's really relevant in permutations. And the formula in combination is n factorial over r factorial times n minus r factorial. While in permutations, the formula is n factorial over n minus r factorial. You can see how there's this extra r factorial. And the one thing that you can take away from all of this as the main difference between the two is order. Our next topic is going to be complementary counting. And this is when we're counting the number of ways that it won't work and then subtracting it from the total. And this is really helpful when there's lots of ways for it to work. And before we do a problem with this, let's just have a bit of practice on solving some combinations. We have 4 choose 3, and that's how we would say it, 4 choose 3, and that's plugging it into the formula, which is n factorial over r factorial times n minus r factorial. You get 4 factorial times 3 factorial, and 4 minus 3 is 1, so you get 4 factorial over 3 factorial times 1 factorial. 1 factorial is equal to 1, so we really don't need that. 4 factorial expands out to be 4 times 3 times 2. 3 factorial becomes 3 times 2, and simplifying, you take out the 3 and the 2 on top and bottom, and you get 4 as your answer. And here's another example, which is select 5 members from 20 people. And that is for you guys to do. Now let's try an example of complementary counting. Sam flips a coin 8 times. In how many ways can he flip at least 2 heads? So first, let's find the total number of outcomes. And for each flip that he does, he can either get heads or tails, meaning there's 2 ways for every 8 coins that he flips, meaning there's 2 to the 8th total outcomes, which is equal to 256. Now we're going to use the complementary counting part. We're going to figure out how many ways he can't flip at least 2 heads, meaning he flips 0 heads or 1 head. And there's only one way to have 0 heads, and that's when they're all tails. And if you plug it into the formula, you'll still get 1. And 8 choose 1, there's 8 different coins that can be that 1 head. Or plugging it into the formula, you can get 8. So doing 256 minus 1 minus that 8, you get your answer, which is 247 ways. Our next topic is going to be sticks and stones. And like the title suggests, we're going to be using sticks and stones. And we mainly use these when we're dividing things among people who are indistinct. For example, how many ways are there to split 7 roses among 3 ladies, assuming they each must at least get 1? Since there's 7 roses, we're going to draw 7 circles to represent the stones. Stones are roses. And then in between each of these, there's a divider. And the divider is to show that how we're going to divide them. And we need to choose 2 of these 6 dividers, because let's say we have a divider there and a divider here. This means we split it up into 3 groups. The first lady will get 1, the second will get 3, and the second will get 4, and the last will get 2. So that's how they'll be split up. That's why we choose 2 of those. So since there's 6 total and we're choosing 2, we're going to do 6 choose 2, which is equal to 6 factorial over 4 factorial times 2 factorial. And 6 factorial expanded out is 6 times 5 times 4 times 3 times 2. Well, 4 factorial is 4 times 3 times 2. 2 is just 2. You might be wondering why I don't include the 1. It's just because You don't really have to include the 1, and I'm too lazy to include the 1. And like I said, you really don't have to, because anything times 1 is that. So we can cancel out the 4 and the 3 and the 2. And then the 6 becomes a 3 because of this 2 that's left over. So we're left with 3 and 5, which makes our answer 15 weights. Our next topic and our last topic of today is Pascal's triangle. And you guys may have heard of this or seen it, and I think it's pretty cool. So what it is, it starts off at 1, all sides are 1, and to get to these numbers, you add the 2 that go down to it. 1 and 1 add to make 2. 1 and 2 add to make 3, 2 plus 1 is 3. And that's how you get it. And you may be wondering, what does this have to do with combinations? Well, here's how. This 1 is technically equal to 1, 1. And this 1, 0 is equal to 1. Here, let me write this. This is equal to 1. This is equal to 1. This is also equal to 1. This is 1, 2, 1. 1, 3, 3, 1. So you can see Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And so that's how it responds. And if you guys know the Pascal's triangle really well, you can use it to find a combination. Rather than doing if you want to do n choose r, you found the n plus 1 row and the r plus 1 term, and that's your answer. And it's much easier than just doing 20 choose 3 by hand, because 20 choose 3 is just 21st row and the 4th term. So our first problem on today is, what is 5 choose 0 plus 5 choose 1 plus 5 choose 2 plus 5 choose 3 plus 5 choose 4 plus 5 choose 5? And if you may notice this is the 5th row of Pascal's triangle. And just so you know, the first 1 is called row 0. And then the 1, 1 is row 1, and then 1, 2, 1, that's row 1, 2, row 2. Anyways, so this is our row 5. 1, 5, 10, 10, 5, 1, which sums to be 32. But here's a little pattern that you may notice. When you add up all of them, and let's just use row 6, 1, 6, 15, 20, 15, 6, 1, that adds up to 64, which is 2 to the 6th. And this adds up to 2 to the 5th, meaning to find the sum in any row, you just take the 2 to the power of that row. So since this is the 5th row and you want to find the sum, it's 2 to the 5th, which is also 32. Now here's our last problem. Kiara and Bob are on the same team with 6 other members. This means there's 8 members. How many groups of 5 that include the 2 are possible? Well, we have our group of 5 here. There's Kiara and there's Bob. And then there's 3 empty spots, meaning we have to choose 3 people from the 6 people that are left, which is 6 choose 3. 6 choose 3 is 6 factorial over 3 factorial times 3 factorial. 6 is factorial is equal to 6 times 5 times 4 times 3 times 2. 3 factorial and 3 factorial, 3 times 2, 3 times 2. And simplifying, we are left with the 5 and the 4, which makes our answer 20 groups. Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrico.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!